All right, good morning. Welcome back to Calculus 1. We are looking at problem 2D here. We are determining the critical points of this function t over t squared plus 1. And we'll go ahead and have a look at what that is. And that's an open interval for everything. Okay, so we don't have a closed interval. So in this case, we don't have to worry about endpoints because there are no endpoints. Okay, so we are dealing with y is equal to t over t squared plus 1 on the open interval between negative infinity and positive infinity, finding the relative max and relative min. So the first thing we do is we take a derivative, okay? So I want derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. T squared plus 1 squared. Don't ever FOIL this out. Just leave it alone. We're going to set this thing equal to 0. Okay, let's go ahead and deal with our quotient rule. So the derivative of t is just 1. So we have a t squared plus 1. And then we have minus t times 2 squared, 2t here. Okay, taking the derivative of this piece right here. And then divided by t squared plus 1 all squared. Set it equal to 0. All right, so let's go ahead and simplify this a little bit. We're going to have t squared plus 1 minus 2t squared, right? T times 2t, divided by this piece here, t squared plus 1 squared equals 0. This is going to be 1 minus t squared over t squared plus 1 squared, set it equal to 0. First thing we're going to do, and this is why I say don't multiply this out. So we're going to clear our fractions. We're going to multiply both sides by t squared plus 1 squared. So we have 1 minus t squared equals 0. Okay, let's go ahead and solve for t. T squared is equal to 1. T will be plus or minus 1. Okay, so since there are no endpoints, we just have to plot the two different points that we have here. So when t is equal to negative 1, what's my y value? When t is equal to positive 1, what's my y value? And since we are dealing with t squared over t squared plus 1, I believe, or t over t squared plus 1, there we go. Get rid of that squared. Okay, we can go ahead and plug those things in. So we have negative 1 over negative 1 squared plus 1. That's going to be negative 1 over 1 plus 1, which is negative 1/2. Right? Hold on to that. We have 1 over t equals 1. We have 1 over 1 squared plus 1. That's going to be 1 over 1 plus 1 is equal to positive 1/2. So it looks like we have our relative min here, our absolute min, and we have our absolute max over here. Because again, we don't have endpoints. So here's our maximum. Just to kind of check what's going on as t goes off to negative infinity and positive infinity. So you don't have to check this, but the limit as t goes off to negative infinity of t over t squared plus 1, right? Since the bottom is bigger than the top, this is going to go to a 0. Same thing with the, because it's squared. When t goes to the limit as t goes to positive infinity, we're again going to end up with t over t squared plus 1, which is also going to go to 0. So we're pretty happy with the fact that we had negative 1, negative 1/2. This is our minimum. And 1 positive 1/2. This is our maximum. Okay, so that would be how to do that problem. Again, there's no endpoints, so you don't have to check boundary conditions or anything like that. If there are endpoints, make sure you do check the boundary conditions. Other than that, I think we are good. So that is how you do problem number 2D, I believe. Yep, short and sweet. So that's a nice problem. But there you go. Okay, so good luck with studying for the test, everybody. Thank you very much for watching the video, and I will see you next time.